Hey, good morning, everyone. Good morning, everyone. How are you all doing? I hope everyone is fine, doing great. Hello. Hello, everyone. Am I audible and visible? Just let me know. Good morning. Good morning, everyone. Good morning. Good morning, everyone. Good morning. Good morning, everyone. So, hello. Good morning. Good morning. I'm good. I'm very much excited to take this session this morning. So, are you all ready for that? So let's just revise in quick seconds basically what we have done yesterday, right? So we have learned certain things, that there are two worlds. One is micro world and other one is macro world, right? Okay. This is the world of electrons, protons, neutrons, atoms, and molecules. This is our world where we live, right? We can see, we can feel, we can measure things, right? Okay. Okay, so but the thing is that all the chemical reactions we are talking about, they occur between atoms and molecules or the ions, right? But to make their sense, we have to carry them in the macro world. Now we have to use one switch out here, and the name of the switch is mole. The moment you press this switch, you can go from macro to micro and micro to macro and vice versa, right? Okay. And yesterday we also learned that a simple act of cutting is not allowed in the micro world, while it is very much a regular phenomena in our world, right? If we cut a potato into two halves, we'll get two half potatoes, right? But out here, if I cut a potato, I'll get two tomatoes, right? With the example of sulfur, we have seen that, right? Yes, because we'll be cutting the nucleus. In chemical reactions, we are not allowed to touch nucleus. All chemical reactions have one thing in common, and that is what? Transfer of electrons. We can only use electrons to have a successful chemical reaction, right? Okay. Okay, and yesterday we were also doing certain questions. Let me repeat one question for you people, that what are the minimum say sulfur, minimum sulfur possible. First one is like say 1 atom. Second one is like say 32 AMU. Third one is 32 gram. Fourth one is 1 gram. Or fifth one I'm giving you is half atom. Right? So which you believe is the correct answer? Come on. What is the minimum possible value of sulfur possible? I want everyone to answer this. Come on. Everyone. And I really believe that, I mean, in 2026, more than what you think in the first go, you have to look at all the options, because in 25, they have given the questions in which you have to go through almost all the options before making sure that you are having the right answer. And this time we saw basically that there were like say multiple answers possible. So be careful regarding that. And now we are having like few of the people giving the right answer, right? Okay, good. See, the correct answer is 1 and 2 both. 1 and 2 both. It's not, see, they both are same thing. They both are same thing. If I take 1 atom of sulfur, right? If I take one atom of sulfur, it contains what? 16 proton and 16 neutron. And we have learned yesterday that weight of one proton is actually 1 AMU and weight of one neutron is also 1 AMU. Will you agree with me? Right? And the weight of an element, of an atom, depends on the nucleus, the nucleons, the protons and neutrons. So one proton has a weight of 1 AMU, 16 proton will have a weight, how much? 16 AMU. 16 neutrons similarly will have how much weight? 16 AMU. So total weight is what? Weight of protons and neutrons. So total weight becomes how much? 32 AMU. Will you agree? So yes, the minimum possible value of sulfur is what? One atom. Half atom, one third atom, division of atom is not allowed. We are not allowed to cut an atom, right? Okay. And no, this is not the right answer. This is the weight of how much of sulfur? Who will tell me? The third. This is the weight of how much of sulfur? 32 gram. Not maximum, Jagdish. This is not maximum. We can have 64 gram of sulfur also, 100 gram of sulfur also, right? If I send you to the market and say, get me 1 kg, 1 kg of sulfur, you can definitely get me 1 kg of sulfur. It will depend on your pocket, right? If you can afford 1 kg of sulfur, you will definitely get it, right? It's not that 32 gram is the maximum. No, it's not maximum. Maximum, so there is no limit for that. It is 1 mole. It is basically 1 mole of sulfur. We come to that. We'll come to that part as well, right? Okay. Let me give you, like, say, similarly, can I give you one more question, right? Okay, tell me minimum possible oxygen, right? Gas. Minimum possible oxygen gas. Gas means, I mean not gas, I'll say oxygen molecule, or simply I'll write down this as O2, right? Let me write down this as O2. Okay, so first one is, like, say again, 1 atom, second is 1 mole, third one is, like, say 1 AMU, fourth one will be, like, say 8 AMU, fifth one 16 AMU, and sixth one also, like, say 32 AMU, seventh one, let me have, similarly we can have, like, say 8 gram, eighth option 16 gram, and ninth option 32 gram. Or, like, say we can have 10th option as well, which says, like, say maybe 1/8 atom. Got to be very careful. Got to be very, very careful. I believe only MSR and Abhi have given the right answer. See, this is actually molecule, oxygen, right? It's molecule. So atom, though, I'm not asking. I'm asking O2 molecule. This is molecule, right? It is not an atom. Oxygen atom is O. I'm asking molecule. So this though is not possible. One atom, no. If it was, like, say 1 molecule, it would have been the correct answer, right? But this is not 1 molecule, this is 1 atom. So this will not be the right answer, right? And like most of people have given the first option. So be careful. I'm saying just have a very good focus. You will be losing your seat. You will be losing the marks, because not because of that answer part, because you lost the focus. I mean, you were not focusing on the question properly. Are you getting it? Most of you have gone with like say 1 and 5, 1 and 6, right? Again, this is O2. Oxygen atom has got 8 protons and 8 neutrons, right? O2 contains 2 oxygen atoms. So again, 8 protons and what? 8 neutrons. So total number of protons is how much? Come on. 16 protons. And total number of neutrons in O2 will be how much? O2 contains oxygen and oxygen. Yes or no? 16 neutrons. And if that is the case, we will be having 16 AMU and plus 16 AMU. Total becomes how much? Come on. 32 AMU. So that is the minimum possible oxygen molecule available to us, right? So correct option is what? 32 AMU. 16 AMU belongs to what? Oxygen atom. But 32 AMU belongs to what? O2. Are you getting it? Are you getting it? So you have to be very much careful that what is happening around. Only 6th was the correct answer, right? 5th is not. 5th is for oxygen atom. I'm not asking oxygen atom. I'm asking what? Oxygen molecule. I mean, let me know that. Is that clear to you people or not? This is such a simple question, but I mean, still we can make some blunder out there. So make sure that we are not going with blunders. You got to work on focus also. I mean, you cannot take the examiner lightly. I mean, they are there to cut your marks, to make sure that, see, when we are like working on more than 20 lakh students, right? So it is extremely difficult to select the people. This examination is all about rejection. They will reject as many as possible. How come they will reject? By giving certain questions which demands focus, conceptual clarity. So this question demanded focus as well as conceptual clarity, because some of you were not even aware that O is actually 16 AMU and O2 is actually 32 AMU. So got to be very much clear, okay? Okay, chalo, theek hai. Chalo, similarly, I'll ask you one more thing. Come on. Similarly, minimum possible value, not value, I mean of helium, right? Let's see how many people are aware of this thing as well. First answer is one atom. Second is 1 mole of helium. Third one is 2 AMU. Fourth one is 4 AMU. Fifth one is 1 gram. Sixth one is say 2 gram, and seventh one is say 4 gram. What do you think is the correct answer? It's a simple one, right? Everyone should be like very much focused out here, right? These are such simple questions and we can't afford to lose the marks out here. I am expecting everyone to give the right answer, everyone, regarding helium, right? And if you are not able to give the right answer, but you please go, I mean, after the class, please look into the basics, fundamentals, right? Whichever books you are having, just go through the basics. Okay. See, the correct answer is what? 1 atom and 4 AMU. Helium contains 2 protons and 2 neutrons. Remember that. So 2 protons will have 2 AMU and 2 neutrons will have a weight of again 2 AMU. Total becomes how much? Total becomes 4 AMU. Are you getting it or not? So some people have given me fourth answer, only one. That is not correct, right? So both first and fourth are the right answer, right? Getting it? Okay, so let's move now, right? Let's move ahead and let's see. Okay, then let's write down certain things, right? Let's take hydrogen atom, let's take helium atom, let's take carbon atom, let's take oxygen atom. I'm just taking some examples, right? Okay, so what is basically the mass number of hydrogen atom? Mass number. You know what is mass number? An atomic number. If I have got an element, suppose say X, then something called atomic number, then something called what? This is called your Z and this is called your A, right? This A is called your mass number and this Z is called your atomic number. Mass number and atomic number, right? And what is atomic number? It is number of protons in the nucleus. And what is this thing? Mass number? This is basically number of neutrons plus protons. Are you getting it? And the weight of the element X will depend on what? Mass number, total number of neutrons and protons, right? So out here, I'm writing the mass number is 1, it is 4, it is say 12 and say 16, right? Getting it? So if I take one hydrogen atom, I mean, what will be the atomic weight? What will the atomic weight of hydrogen? I mean, it will be like say 1. How about this one? It will be like say 4. It will be like what? 12 units and what? 16 units. Right? And if I'm looking at the microscopic world, then what is the atomic weight? Then what is the atomic weight in the microscopic world? It will be 1 AMU. How about this one? 4 AMU. How about this one? 12 AMU. How about this one? 16 AMU. Right? But if I want to go into what? Macroscopic world, right? Then what you should do? You should apply an operation called into NA. Collect these many atoms, right? So 1 AMU into Na will give you how much? What will be the weight of 1 mole of hydrogen atoms? It will be basically what? 1 gram. 1 gram. Let me explain you in case you do not know this thing. Okay, I'll explain that. See, you know what is 1 AMU? Weight of 1 proton, which is almost equal to what? Weight of 1 neutron. That is called 1 AMU, and the value of 1 AMU approximately is 1.6 into 10 to power of minus of 24 gram. Is that clear? Right? Now see this thing. If I take reciprocal, say let's take 817. You know table of 817? Sir, we do not know table of 2 properly. You are asking the table of 817. But if I ask you to multiply by the reciprocal of 817, what I'll get? I'll get what? 1. Similarly, if I ask you the table of like say 1245, oh sir, I do not know this table as well, but if I multiply by the reciprocal of 1245, I'll again get what? 1. So we have got this thing, 1.6 10 to power of minus of 24 gram, right? And if I multiply by the reciprocal 1.6 10 to power of minus of 24, like this and this are basically what? Reciprocal, right? So this will become what? 1. And we have a gram out here, it will become what? 1 gram. Now see this thing. If I ask you one thing, that what is the value of Na? What is the value of Na? It is basically 6 into 10 to power of minus of, or say only, 23. Yes or no? 6 into 10 to power of 23. What I'm saying is that why this value of Na is 6 into 10 to power of 23? Why this is not my mobile number, right? Why it is not your mobile number or any other number? Why is this value approximately 6 into 10 to power of 23? Why? It could have been any number. It could have been any pin code. But the idea is that it is not like any other number. Your mobile number, my mobile number, any other number, right? My weight, your weight, the weight of earth, whatever. Why is this the value of Na 6 into 10 to the power 23, the value of Na? Why? Why scientists basically boiled down to this value itself, not any other value? The reason is this one, right? The reason is this one, right? Because this value is on solving, you will get this value 1 upon 1.6 10 to the minus 24 is nothing but what? Na. So the purpose of the scientists was 1.6 into 10 to the power of minus 24 gram into, this is what? When you will solve it, you'll get approximately 6 into 10 to the power of 23. When you will solve it, this 23 and it will be like say 10 to the power of minus of 1. Now 6 into 1.6 is almost like 10. So 10 into 10 to the power of minus 1 is again 1, right? So the purpose was that when you move from microscopic world, what is this thing? 1 AMU. This value 1.6 10 to the power of minus 24 gram is what? 1 AMU, and this is what? Na. The purpose was that when you multiply the 1 AMU by Na, you will get 1 only, and in the macroscopic world, you will get what? The same weight in terms of gram. So if I take 2 AMU and multiply by Na, now you know that AMU and Na are what? Reciprocal. It will cancel out. I'll get what? 2 gram. So I told you yesterday that the ID, the identity, the Aadhaar card of any element is what? Residing where? It is residing where? The ID of any element resides where? In the nucleus, right? So this nucleus should not change. If this nucleus changes, ID changes, element will change, right? So for example, if I begin with like say maybe 31, 31 is the ID of phosphorus, and on multiply by something like say Y, I go into what? Macroscopic world, from microscopic world, and I get like say 32. Then that will be wrong, because 32 the ID of what? Sulfur. The ID should not change. The ID should not change, and the only way the ID will not change is that multiply X and Y in such a way that they both are what? Reciprocal. So, well, traversing from microscopic world to macroscopic world, like the ID of phosphorus should remain the ID of phosphorus here also. If it is 31, it should remain 31 here. It is 31 AMU here, and I multiply by Na, I get what? 31 gram. But ID remains same. ID does not change. If I talk about sulfur, in the microscopic world, I'll get what? 32 AMU. Into what? Na. They both are reciprocal. Will cancel out. Will give what? 32 gram. Right or not? Now 32 gram is definitely something which I can sense, I can measure, I can feel that stuff. But 31 AMU, I can't even see that. I can't measure that. Practically it is not possible to measure the weight of one atom of phosphorus, right? But when we collect these many atoms of phosphorus, I'll get a significant weight which I can feel, measure, or I can do whatever I want to do. Is that clear? So this switch we were using, this switch was mole, and 1 mole is nothing but what? Avogadro number of entities. Avogadro number of entities. So that's why the value of Na is like say 6.023 into 10 to the power of 23. It is not any other arbitrary value. Is that clear to all of you now? So let's go to this page we were like earlier. We were here, right? So we are out here in the microscopic world, and we have to go to what? Macroscopic world. Now you will multiply by Na to go where? In the macroscopic world. But when you multiply by Na, we all know that this AMU and Na are reciprocal, and I'll get what? 1 gram. Similarly out here into Avogadro number, Na and AMU will cancel, and I'll get what again? 4 gram. Out here into Na, use the switch to go into macroscopic world. Na and AMU are reciprocal, and I'll get what? 12 grams. Similarly, into Na out here, I'll get what? 16 gram. Now, when you measure the weight of 1 mole of any substance, or say we're talking about atoms out here. If I measure weight of 1 mole of the atoms out here, I'll get the weight in gram, and this is called gram atomic weight. Gram atomic weight. Are you getting it or not? So see, AMU, 1 AMU is what? 1.6 into 10 to the power of minus of 24 gram, right? Now this is such a very, very small unit. This small unit is used to measure the weight of what? Of atoms. Of molecules, of protons, of neutrons, of electrons, right? This is the world of microscopic, right? Nature. So we are going to measure the microscopic objects with which unit? 1 AMU, right? It will look very absurd to weigh an electron in terms of gram. So for the sake of simplicity, we measure in what? In terms of what? AMU. Is that clear? But in our world, we cannot use that AMU as a unit, right or not? Suppose, say if I ask, what is my weight? So I might say that it is like maybe 70 kg, right? But if I ask you to give my weight in terms of AMU, it will look quite absurd, right? That every time I have to do what? 70 and in 70 kg, then first of all convert into what? Gram, into 1000, this much of gram. Even I cannot say that stuff, that my weight is 70,000 gram. It looks absurd, right? So for the sake of simplicity, we use like say relevant units. Are you getting or not? Is that clear? So what I'm saying is that in the microscopic world, what is the unit of measurement of weight? That is basically AMU. But in the macroscopic world, the unit should be what? Gram. Right or not? Or maybe kg as well if you are having significant weight, right? Now, this is the unit which will be used to measure the weight of like say 1 atom, 2 atom, 3 atom and 4 atoms like that, right? Maybe 1 molecule, 2 molecule, 3 molecule. But if I collect significant amount of those atoms or say molecules, I'll measure them in terms of what? Gram. Now to go from here to here, I'll multiply by what? Na. Now Na and AMU are reciprocal, they will cancel out and the ID will remain same. Suppose say for example, if I take CO2, like I'll come there, let's take nitrogen atom. So nitrogen atom has got mass number as what? 14. So the weight of one nitrogen atom will be how much? 14 AMU. But if I multiply it by Na, I'll go into what? Macroscopic world and the weight will what? 14 gram. Right or not? 14, the ID remain same. This is called gram atomic weight and this is simply called atomic weight. Are you getting it? That is like say in terms of microscopic nature. So if you will see some questions or you must have seen some questions earlier as well. So they may say that atomic weight of oxygen is suppose say is 16. They give you 16. They don't give you 16 AMU or they don't give you 16 gram. They simply give the atomic weight of oxygen is what? 16. Now it's your freedom that if you want to work in the microscopic world, you will take 16 AMU, and if you want to work in the macroscopic world, you will take what? 16 gram. The ID remain same, and that is the beauty of Avogadro number. When you multiply this by Na, you immediately transfer from micro to macroscopic world, and by doing so, the ID remains same. I am working with oxygen here, I am working with oxygen here as well. Are you getting that? If it becomes 15, I am working with something else, but not with the same oxygen atom. Is that clear? So to make the ID same, the scientists, the chemists have brilliantly invented the Avogadro number. I'll say rather that Avogadro number is one of the beautiful, most beautiful invention done by what? Chemist. Now, whichever part of universe you live, I mean, this entity will remain same. Whatever you do. So the idea is that Avogadro number was designed in such a way that this and this, they remain reciprocal. If they are reciprocal, are you getting it? Suppose say if not AMU, this was unit say X and this Avogadro is suppose say Y, right? If this is AMU and that is Avogadro number, they are designed to cancel each other. They're basically what? Reciprocal. They are what? Reciprocal. So if someday someone comes and changes the value of AMU to like say maybe U dash, right? In that case, this Avogadro number will also change. Avogadro number will also change to make sure that we are getting what? 1. They both are always what? Reciprocal. Is that clear or not? Is that clear or not? Whatever happens to this AMU value, the value of Avogadro number will change automatically to get what? This as 1. Like they are interdependent. They are not independent entities. It was designed to make sure that when you multiply this AMU with what? Avogadro number, they should get what? 1. If you change the unit, if you this is say AMU and this is say Na, they will always like what? 1, right? And if I have got say different value of AMU, say U dash, then Avogadro number will also change. It is not a fixed number, right? If someone says now, instead of carbon, I want something else to be the standard unit, right? Or standard atom. In that case, they both will get cancelled up. To get what? This as 1. Yes or no? So let me ask you one question now. Let me ask you one question. That question says that if U dash, the new AMU, right? New AMU U dash is equal to 1/6 of one atom of carbon 12. One atom of carbon 12, right? Then find weight of 1 mole of carbon atom. 1 mole of carbon atom. I'm not asking the weight of one carbon atom. Yesterday we have done some questions, right? Right. You got to listen to me, yaar. You got to listen to this, na? Don't focus out here. And I'll write it, but your job is to focus what I'm saying. One atom of carbon 12. When you do not know, then these kind of things happen. Once you get what I'm saying, there is no need for that writing kind of thing. Solve it. Is weight of 1 mole of carbon atom. 1 mole of carbon atom, I'm saying. Sir, you said NEET 25 paper was easy, but it was very tough. Why? This question is a contradiction unto itself. It was easy from my perspective. It was easy from the perspective of the people who have done the basics very right. And I'm talking about physical chemistry. Like, I'm not talking about the overall paper, right? If your concepts are clear, it was a bit lengthy. I can agree with that stuff, right? It was tough basically in the sense that it was a bit lengthy, and this paper required ultra clarity of certain things, right? For which probably the entire nation was not ready. If given enough time, I believe people could have again scored like say 700 plus, many people. See, understand one thing. Like, let's first of all do this thing again. See, this is, if I talk about weight of one atom, the two questions I'm asking, right? If I'm changing the value of AMU, then weight of one atom, right, in terms of new unit, are you getting it? And I'm asking this question as 1 mole of carbon atom. There are two different questions I'm asking. So let me solve first of all for one atom of carbon, right? We will not say carbon atom. Let's take, say, again, maybe say nitrogen atom. Let's take the same thing, what we have done last time, nitrogen atom. Understand this thing. So now your U dash is what? See, one atom of carbon 12. You know that one AMU is equal to what? 1/12 into what? One atom of carbon 12. right or not? Right? So out here, this U dash is what? 1 atom of carbon 12 by 6. So can I say that one carbon atom will have, like, say, 6 U dash, and out here 1 atom of carbon 12 is what? 12 AMU. So both are what? This is what? 6 U dash is equal to what? 12 AMU. So can I say U dash will be what? 12 AMU upon 6. This happens to be like what? 2 AMU. So U dash is what? 2 AMU, new unit, right or not? And in the old unit, if I take one nitrogen atom is what? 14 AMU, 14 AMU, right or not? And now I know that if I look up here, U dash is what? 2 AMU. So AMU, 1 AMU is what? U dash by 2, U dash by 2. Yes or no? If this is U dash by 2, in that case 14 into U dash by 2. This will be how much? 7 U dash. 7 U dash. Is that clear to people? For one nitrogen atom. That's the answer, right? For one nitrogen atom. Is that clear? Now, when I am asking about 1 mole, I told you that if this is AMU, and what is 1 mole? What is 1 mole? This is what? Na in normal times, right? This will give you what? 1 AMU into Na will give you what? 1 gram. And if I take, like, say, this is, like, say, U dash, then this will become what? Na dash, new value. Avogadro number will change if I change it. They both are designed in such a way that I always get what? 1. Are you getting or not? So in case if I change the value of this AMU, atomic mass unit, so I have made it what? 1 AMU is what? U dash by 2. So this is what? U dash by 2, right or not? In that case, this N dash A will become what? 2Na. Are you getting it? So this and this will cancel up. And I'll get what again? What? 1 gram. I'll get what? 1 gram, always. They both are interdependent. If I change the value of AMU, the value of Na will also change. If this becomes half, this will become double to get what? 1 gram. So if I talk about 1 mole of nitrogen atom, 1 mole of nitrogen atom will always weigh what? How much? 14 gram. Whatever the value of U dash you take. Is that clear? So let's sum it up now. See, if U dash is, say, 1 by 6 into 1 atom of carbon 12, right? In that case, one atom of nitrogen will have weight how much? 7 U dash. 7 U dash, right or not? But if I talk about 1 mole of nitrogen atom, 1 mole of nitrogen atom, right? Then the weight of 1 mole of nitrogen atom will be how much? 14 gram. Always. Always. Is that clear? So let me talk about this thing again. If I'm talking about 1 atom of oxygen, what will be its weight? Normal weight of nitrogen is what? 14 AMU. 14 AMU will become what? 7 U dash. So this is normally what? 16 AMU. It will become how much? 8 U dash. Yes or no? 8 U dash. And what will be the weight of 1 mole? Weight of 1 mole of oxygen atom. How much? 16 gram. This though will remain same. And that was basically the reason behind this reciprocity. 1 AMU into Na will always give you what? 1. They both are always what? Reciprocal. They both are what? Reciprocal. Always. If you change the value of AMU, Na will also change in such a way that they both again remain reciprocal. Is that clear? Let me talk about again, maybe, say, helium. 1 atom of helium, right? 1 atom of helium. Now in normal unit, I mean, it is what? 4 AMU. But now with this unit, it will become how much? 2 U dash. Is that clear or not? And this will become how much? 1 mole. 1 mole of helium atom. 1 mole of helium atom will always be how much? 4 gram. It will always be 4 gram. So if you change the value of Na, or say change the value of atomic mass unit, they both are interdependent. They both will change in such a way that they are cancelling each other. They both are always reciprocal. Is that clear or not? If this is say U dash, then we have got Na dash. It will again become what? 1 gram. Whatever the value of AMU, Na will change accordingly to make sure that we are having the same value of 1 mole in whichever world you are talking about. Is that clear to all of you? But is that clear or not? So I'll give you one more question to have that clarity, right? Because I'm having an intuition that they can ask you these questions, and these questions, they always trouble the people. Shall I ask you one more question to get this clarity? And this time you will give the answer, right? Let's try one more question. Okay, let's say if 1 U dash, new atomic mass unit U dash, is equal to 1 by 24 into 1 atom of carbon 12, weight of 1 atom of carbon 12, right? Right? This is all weight of 1 atom of carbon 12, right? Then you have to find out weight of one atom of nitrogen, and again you have to find out weight of 1 mole of nitrogen atom. 1 mole of nitrogen atom. Come on. Will come. Weight of 1 atom of nitrogen and weight of 1 mole of nitrogen atom. So first of all, let us make one thing very clear. Out here, this 1 U dash is equal to what? Or you know that 1 AMU. 1 AMU is equal to what? Weight of 1 atom of carbon 12, right? Isotope upon 12, right? And so can I say weight of 1 atom of carbon 12 is what? 12 AMU, right? So if I replace this value out here, this will be, so let me first make it clear, right? Out here, 1 U dash is equal to, what is the weight of 1 atom of carbon 12? 12 AMU upon what? 24. This is what? 2. So 1 AMU is equal to 2 U dash. Is equal to what? 2 U dash. Once it is established, now we can go for what? Weight of 1 nitrogen atom. Weight of 1 nitrogen atom, and over here we'll solve for weight of 1 mole. 1 mole of nitrogen atom. So weight of 1 nitrogen atom in the old unit is what? 14 AMU. But 1 AMU is what? 2 U dash. So this will become what? 14 into 2 U dash. How much? 28 U dash. How many of you got this answer? 28 U dash. Okay, right. 28. Got it. Very good. And what is the weight of 1 mole of nitrogen atom? I told you that whatever the value of U dash it is, 1 by 2, 1 by 3, 1 by 4 AMU, doesn't matter at all, right? So out here, this U dash and Na dash will change in such a way that I'll get what? Always what? 1 gram, right? So weight of 1 mole of an atom will always be what? 14 gram. Always be 14 gram. Good, very good. And don't say 14. In the macroscopic world, say 14 gram. In the microscopic world, say 14 AMU. Right? Getting it? So give your clarity with the respect to answer, right? Achha, in the same question where we are having what? 1 AMU. Let's clarify. 1 AMU out here is how much? 2 U dash. So with respect to this thing now, tell me what is the weight of 1 atom 1 atom of oxygen, and what is the weight of 1 mole? 1 mole of oxygen atom. Come on. Weight of 1 atom of oxygen. If 1 AMU is equal to 2 U dash. Oxygen atom, we all know, in the original unit of 1 AMU, right? It is what? 16 AMU. 16 AMU. 8 protons and 8 neutrons, right? And in this new unit, when 1 AMU is equal to what? 2 U dash. So 16, 1 AMU is how much? 2 U dash into 2 U dash equal to what? 32 U dash. Right? And how about weight of 1 mole of oxygen? It will be always 16 gram. Whichever part of universe you live, you go in the black hole or wherever, right? 1 mole of oxygen atom will always have this kind of weight, right? I hope now it is very clear that if they give you this kind of question, you will be the first one to answer it, and that too with confidence and panache, right? So shall we move ahead now? I hope that enough of the practice of these things. Whatever the unit of AMU, weight of 1 mole of any element will remain same as was earlier when 1 AMU was 1.6 10 to the power minus 24 gram. Clear? Chalo, theek. So now let's establish it for once and all. Hydrogen, say helium, say carbon, nitrogen, oxygen. I'm talking about atoms and their mass number being 1, 4, 12, 14, 16. So in the microscopic world, and in the macroscopic world, the button is what? Avogadro number. What is the weight of hydrogen atom? 1 AMU. When you multiply by Na, you will get what? 1 gram. And this is called gram atomic weight. This is called gram atomic weight. Atomic weight expressed in terms of gram. Right? Okay. And if I take this thing for helium, it will be 4 AMU. And you want to go in the macroscopic world, multiply by Na, and you get what? 4 gram. And this will be the gram atomic weight of helium. If you take carbon, this will be how much? 12 AMU for 1 atom. 12 AMU for 1 atom, and you multiply by Na, you will get what? Come on. 12 gram. That is what? Gram atomic weight of carbon. Similarly, if you take nitrogen, 14 AMU for 1 atom. 14 AMU for 1 atom and multiply by Na, and you will get 14 gram. And that is called gram atomic weight. So gram atomic weight basically is what? Weight of 1 mole of the collected atoms. Theek? Oxygen. Come on. 16 AMU for 1 atom, and take 1 mole of them, you will get what? 16 gram. 16 gram happens to be the gram atomic weight of oxygen. Okay? Clear? Now let's take. Similarly, let's talk about some molecules now. Some molecules. Again, we'll talk about them in the, like say, microscopic world, and then we'll travel toward macroscopic world. By doing what? A simple operation. Multiply by what? Avogadro number. So let's take few molecules like hydrogen. So what is the molecular weight of hydrogen, I mean, in microscopic world? Come on, that will be called your molecular weight. Molecular weight, right? Molecular weight. How much? 2 AMU, right? Into Na, ID remains same, and I get what? 2 gram. This and this will always get cancelled. They are always reciprocal. So 2 AMU becomes 2 gram. Let's talk about, like say, nitrogen N2, the molecule, right? Come on, tell me. This will be 28 AMU. 28 AMU. And take 1 mole of it. I'll get what? 28 gram. Now, this for molecule, this is called gram molecular weight. wait. I got it. Gram atomic weight, right? ठीक. So gram molecular weight. So 2 gram happens to be the gram molecular weight of hydrogen, and for nitrogen gas, it happens to be 28. What? Gram molecular weight. Is that clear? Let's talk about CO2. CO2, it is 44 AMU. 44 AMU, right or not? And in terms of macroscopic world, or say gram molecular weight, it will be 44 gram. So whenever you express your molecular weight in terms of gram, is called gram molecular weight. I hope that is now very much clear, that the difference between molecular weight, gram molecular weight, atomic weight, and gram atomic weight. Is that clear to all of you now? Okay. Okay. If it is clear, let's move further, right? Just before moving forward, I mean, if you guys have given this 25 paper, like which part of physical chemistry you thought was like more difficult for you people to handle? The thermodynamics, there was no question of ionic, surprisingly, right? But that doesn't mean that they will not give you ionic next time. Like I'm having a hunch that maybe next time ionic might have some weightage out there, right? So which part of physical chemistry you people believe that was difficult to handle? Just I'm asking your opinion. Or I mean, for you people, it was like thermodynamic, that one question of crystallization, right? Ionic, there was no question on ionic. I mean, while preparation, I'm not saying while preparation, I'm saying in the paper of 25. Thermodynamics. I mean, okay, that is like a universal thing you were having the problem with. I believe chemical equilibrium, kinetics, atomic structure, like those were simple one, right? Electro was difficult. Achha, you, Varshita. Okay, I'm your 25 student. This time I'll secure medical college. Thank you so much for support during my journey. I mean, wish you all the best, and I'm very much proud of you, Varshita. Keep moving and keep doing like good things in your life. I mean, you will do good, really. You will really do good. I'm proud of you. Kinetics. Mallikarjun, kinetics. Okay. Kinetics was simple one. Never mind. I mean, this time, I mean, in case you are going to prepare, we'll make sure that you become the master and blaster of kinetics as well, right? Chalo, let's move forward now. Okay, so there are one more thing, like say if you, acha, okay, let's do this thing as well. Then there is a terminology called actual weight, of atom or say molecule. What is the actual weight of an atom or molecule? It's a terminology, right? And one should be very much aware of this thing. It means you have to express the weight of one atom or say one molecule in terms of gram. In terms of gram, right? In terms of gram. Weight of one molecule or one atom. Actual weight of an atom or molecule is what? Weight. This is what? Weight of one atom or one molecule expressed in terms of grams. Weight, I repeat again, it is the weight of one atom or one molecule expressed in terms of gram, right? Show me thumbs up if you are getting what I'm saying. Actual weight of an atom or a molecule is weight of one atom or weight of one molecule in terms of gram. Is that clear to you people? Because I'll be asking you the question out here, and we will be understanding how we can go wrong here as well. Varshita, you were in basically this Pengaluru campus? Okay. Right. Right. Okay. Okay, then answer this question now. Answer this question if you have got it. Okay. The question, find actual weight. Find actual weight of say carbon atom, right? First option is 1 gram, second is say 12 gram, third one is say 12 AMU, fourth one is say 1 AMU. 12th line, 12th and offline, which topic will you start, sir? Will be beginning with basically, I believe, some basic and fundamental things again, right? So I will advise you that join as early as possible, because you will get more days, you will have more elbow room as compared to your other competitors, right? Twelve gram, second option. Okay, most of you are saying second option, right? Getting it. Given the answer, all of you very much confident? Can I lock it? Shall I lock it? The second one, 12 gram, right? Only Ambati has given me the right answer. This is Senihar, Ambati. The answer is none of these. None of these. Go back again. The actual weight of an atom and molecule is what? Weight of one atom or one molecule. Weight of one atom or one molecule expressed in terms of grams, right? You think that weight of one carbon atom will be 12 gram. 12 gram though I can sense, right? One atom of carbon I can't sense, and no one can. Are you getting or not? Your physics teachers will be very angry on you people, right? They will be having a heart attack right now if they are watching this video. They have a tough time ahead. So if you look at that, weight of one carbon atom is not 12 gram. It is basically one carbon atom is actually 12 AMU, but we have to express that weight in what? Grams. And I told you what? That 1 AMU is equal to what? 1.6 into 10 to power of minus of 24 grams. So you have to convert the AMU into what? Grams. So the correct answer will be 12 into 1.6 into 10 to power of minus of 24 grams. Weight of one carbon atom cannot be 12 gram, right? Boys, I mean, if you're having a girlfriend, please don't tell her that you were not able to solve this thing. For you people, that weight of one carbon atom is 12 gram. And if weight of one carbon atom is 12 gram, by God, your weight is how much then? Right? Getting it? So you multiply that thing, you'll get 1.92 into 10 to power of minus of 23 grams. Is that clear or not? Is that clear? So you have to have that conceptual clarity. If you don't have that clarity, you are in all kind of trouble. So science is all about conceptual clarity. If you are having that clarity, everything is okay. If not, then you are heading for a big trouble, right? Getting it? 12 AMU. No, weight of one carbon atom is 12 AMU. No doubt it is correct. But I'm asking actual weight. Actual weight is expressed in grams, not in AMU. I told you here, and you gave me thumbs up as well, that what is the actual weight of one atom or molecule? It is what? Weight of one atom or one molecule expressed in terms of gram. So you have to convert AMU into what? Gram. Is that clear now? Is that clear? Pawan Kumar, is that clear? So that's what I'm saying. You people should not think, see, very much highly about ourselves, right? So if I ask you, I mean, normally what happens, we people normally overestimate ourselves. So if I ask you, I normally ask people that, like on an IQ level, right? Say, maybe say out of 10, how much rating you will give? Chalo, you people give me on an IQ scale, right? Out of 10, how much you will rate yourself? 5, 6, 7, 8, 9, 10. How much? Come on, you can give me the marks. 3, 0. Oh, no, you are getting very modest. Trust me now. No, see, you are getting afraid right now. But normally you will not say so in front of your friends. In your Naruto, you are saying 3,000. 3,000. Wow, great. And what are you doing now with that IQ? 9. Janvi giving 9. Mallikarjun 9. भैया 9 दे रहे हो तुम लोग. I want to let you know that Einstein will be given an average score of like 7.2, 7.3. And you're getting 9. So with people with 9 IQ level, we should be the superpower. We should be the superpower, and like USA should be working under our own tutelage. Keeping brain only. Okay. Newton would have been given 7 kind of thing, right? And people are having 6, 8, 5, my God. So that's what I'm saying. People overestimate about their own intelligence, right? Why the fact is that people are not getting this thing as well. People are not getting the answer of simple fundamental questions, right? So it's not about that, sir, which chapter you will begin, which topic you will begin. I'm saying please come early and join the bandwagon. We are going to do something really, really serious. I mean, what I'm saying, if I have given in this test like these 5, 6 questions only, which we have discussed today, like I believe that most of you will score like out of 6, almost 0 kind of thing. Are you getting up? Maybe say 1, maybe say 2. In simple fundamental things, which normally they don't ask it. So if we are like getting like very low score in these kind of questions as well, now think of that when they will be giving a really, really good question, deeper questions like conceptual fundamental questions of some gravity. In that case also, you will be in all kind of trouble. So that has been our story. We have been thinking all the time around that we are like pretty good. We are, but we are not able to utilize that potential. The potential is there. We have to actualize it. Is that clear? Right? So shall we move ahead now? Can I give you one more question now? So what you are doing, when you get an unknown question, the question which you're looking for the very first time, or a concept you have done for the very first time, and you are asked to do a question, you normally go wrong. But if I give you a similar question, Samin, you go right. So what I'm emphasizing? I'm emphasizing that the power of revision. Once you revise, you grow, you become stronger, right? The reason is that, so maybe the level of question was out here, and initially when you were not aware of this topic of this question, you might be here. So you were not able to tackle the power of this question. But once you have solved it, now you will be up here, at least up here. And once you do it twice or thrice, you might even go higher. And now taking down something which is like weaker than you is comparatively easy, because the level of question will not go up. But you can raise your level by doing revision, practice revision, and asking some fundamental questions, right? And mind you again that when you are like coming out here in the campus, don't think that, sir, my question is a very silly question, right? People have grown a lot by asking all these silly questions. No question is silly. No question is silly, right? It's just that you are not aware of those things. If you are aware of those things, this is no more silly now. Are you getting it? Don't think that what others will be thinking about you people, right? People don't think about you. People are so much embroiled in their own life, they seriously don't have that much of time to think about you. We unnecessarily think that what others will be thinking, what they will be doing, that stuff or not, right? Wait a minute. I got to do something. Now, am I audible? Now audible. So you have to find actual weight of water molecule. Come on, solve it. Give me a quick answer now. Ray, Smiley, MSR, actual weight. I'm asking actual weight. What is actual weight? Sumalata, Srimani, Chandana, Ben Stokes, तुम क्रिकेट ही खेलो, तुम यहां क्या कर रहे हो? निहारिका, ये तुम कैसे कैसे आंसर दे रहे हो मेरे को? What kind of actual weight is? What is actual weight? Actual weight is weight of one molecule of water in grams. You believe that weight of one molecule is invisible, will be 18 grams. 18 grams, if I put something out here on your hand, you will feel it. But one molecule of water, you won't. अरे जयेश नायक क्या कर रहे हो तुम लोग? It is not 18 gram. See, first option I'm giving you 18 AMU, second 18 grams, third one 1 gram, fourth one 2.88 into 10 to power of minus of 23 gram. Chalo, tell me now. Fourth option. Right, much better. So actual weight is basically weight of one water molecule, in grams. So technically weight of one water molecule is 18 AMU, right? But if I take 1 mole of water molecules, they will have weight of how much? 18 gram. So 18 gram is the weight of 1 mole of water molecules, but not of 1 molecule of water. So weight of one molecule, this is weight of what? One molecule in AMU. You have to convert AMU into what? Grams. So again, and what is 1 AMU? I've just told you 1 AMU is 1.6 10 to power of minus of 24 grams, right or not? So please convert it. So instead of AMU, write down 1.6 into 10 to power of minus of 24 grams. This will be equal to 2.88 into 10 to power of minus of 23 grams. Weight of one atom, one molecule in terms of gram will be a very, very less value, extremely less value like this, right? Is that clear? Only fourth. This is weight of one molecule of water in terms of AMU. In terms of AMU. What is 18 gram? 18 gram is the weight of 1 mole. 1 mole of water molecules. Yes or no? And this is actually weight of one molecule of water in grams. In grams. Is this confusion still persisting or what? Achha, can I give you one last question? One more question to get the clarity, right? Okay, I'm giving you one more question, right? Let's try it out. Let's try it out. You will solve it, right? Come on. Find out. Find actual weight of what I can give you. Chalo, helium atom, right? Find actual weight of helium atom, right? Karo usko. First option I'm giving you 4 gram, second is 2 gram, third one is 2 AMU, fourth one is 4 AMU, like fifth one is none of these or whatever, or give me the correct answer. I mean, right. So actual weight of helium atom is weight of one atom of helium expressed in terms of gram. Now I know that for helium atom it is what? 4 AMU. 4 AMU. Weight of atom molecule is measured in AMU, right? Okay. Now I have to express this in terms of what? Grams. So I'll convert AMU into gram by multiplying 1.6 10 to power of minus of 24 grams. Is that clear? Is 6.4 10 to power of minus of 24 or 23? 24 or 23, what are you writing? 23, 24. Come on. 23. 25. तुम कैसे आंसर दे रहे हो मुझको यार? Now half of the class saying 23, half saying 24. Like 1.6 into 4 is what? 6.4, na? 6.4 only. So this is untouched. So 10 to the power minus of 24 gram. So the right answer will be, if I write down the fifth option now, 6.4 10 to the power of minus of 24 gram. Right? That will be the correct answer. So we have to work on our calculations aspects only. So that will need a lot of practice. And that practice will be even better if we join early out here. And because I mean, when you join early, we will be having more time. So we will be investing. MSR, I mean, but we don't write this thing as 64 into 10 to the power of minus of 25. Normally we don't write. It's not a scientific, I mean, like language, right? Like scientifically, you can write it out as 6.4 into 10 to the power of minus of 24 gram itself, right? Normally this is not preferable, okay? Chalo, let's do something more now. Okay, we have some time as well, right? Come on. So then there is something called how we can write down 1 mole of anything. How you can write down 1 mole if you are looking for atom. Sir, AMU, 4 AMU is also correct. Nayak, see that. Actual weight is expressed in terms of gram. You are not understanding. See, beta, suno meri baat ko. Let's talk about helium atom. Helium atom, I'm talking about 1 helium atom, right? 1 helium atom, the weight is 4 AMU. 4 AMU, and that is correct, no doubt about it, right? But if they're asking you actual weight Actual weight is basically a chemical terminology which is actually equivalent to saying that weight of one atom expressed in terms of grams. Expressed in terms of grams. This is not incorrect. This is correct basically. This is correct, right? But what I'm saying, if you have to express it in terms of gram, you cannot write down AMU now. So you have to convert AMU into gram by doing what? 4 AMU will be equal to what? 4 into 1.6 into 10 to power of minus of 24 gram. I have to write this answer in terms of gram, not in terms of AMU. Is that clear now? Nayak. That is correct answer, but in terms of what? AMU. They are looking for what? Gram. So you have to convert AMU into gram, and 1 AMU is 1.6 into 10 to power of minus of 24 gram. Is that clear? Nayak now. दोबारा गलती नहीं करना यार ये सब चीजों में. ठीक. See, there are again, these are all chemical terminologies. You should be aware of these things. They may not always write 1 mole. Like there are 3 different ways where they can give you the definition of 1 mole in different ways, right? 1 mole, if you are looking basically at atom or say molecule or say ions, right? 1 mole, if you are talking about atom, it can be written as 1 gram atom. 1 gram atom. Let's say, so 1 mole is equivalent to what? 1 gram atom. This is written not as 1 gram an atom. This will be read as what? 1 gram atom. This is the phrase gram atom, right? 1 gram atom. It is not 1 gram of atom. It is 1 gram atom, right? So similarly, if they have to give 2 mole of an atom, this will be what? 2 gram atom. So how you will read it? Like say it is 2 gram atom or 2 gram of atom. Which one is correct? The first one or the second one? Which one is correct? 2 mole of an atom is equal to what? 2 gram atom or 2 gram of atom. Which one is correct? First one is correct, right? It's a chemical terminology. You should be aware of this thing. But when they gave this question, people in hurry, since most of the time you will be reading that, like say 2 gram of oxygen atom, say 5 gram of oxygen atom, right or not? But this will be incorrect. How? I'll give you a question and make you understand those things. Now, if you're talking about molecule, 1 mole of a molecule is written as what? 1 gram molecule. 1 gram molecule, right? And it will be read as what? Gram molecule, not as what? 1 gram of molecule. Be aware of that, right? So if I have to write down say 5 mole of a molecule, right? 5 mole of molecule, it will be written as what? 5 gram molecule or 5 gram of molecule. What you will read it? First one or second one? Which one will be correct? Sorry, my mistake. 5 gram molecule, first one, right? Correct. And similarly, if we have to look at the ion part, so 1 mole of an ion is equal to 1 gram ion. This is correct, not 1 gram of an ion, right? This will be incorrect. And if I say 4 mole of an ion, then it will be like say 4 gram ion, 4 gram of iron. Which one is correct? First one is correct. Out here, this one is correct. Out here, this one is correct. Is that clear? Now, can I ask you some questions based on that? Can I ask you some questions? Right? Okay. Okay, tell you one thing now. Question. Find weight of, say, 12 gram atom of carbon. 12-gram atom of carbon. First option I'm giving you is 12 AMU. Second, 12 gram. Third, 144 gram. Fourth, none of these. Come on. 12 gram atom. Which one you believe is the correct answer? Right, I believe that most of you are giving the right answer right now. See, it should be read as 12 gram atom. 12 gram atom, which means it is 12 mole, because gram atom is nothing but mole. 12 mole of carbon. Now, 12 mole of carbon is what? 12 into 12. Because 1 mole of carbon is how much? See, 1 mole of carbon has a weight of what? 12 gram. So 12 mole of carbon will have how much weight? 12 into 12 gram. How much? 144 gram. Is that clear? Is that clear? So answer is what? Third one. 144 gram. Shall I ask you one more question now? Okay. So, okay. Question says that which has maximum weight? Which has maximum weight? First option I'm saying, it is say 1 carbon atom. Second one is 1 mole carbon. 1 mole carbon, right? 1 mole of carbon. Third one, it is 1 gram atom of carbon. Or fourth one is 12 gram of carbon. 12 gram of carbon. Which has maximum weight? Which has maximum weight? I believe Abhi and Ambati are the only people out here. Acha, now we have got Janvi also, right? Teja also, Abhi also. Niharika, very good. Soumya, very good. Punanjali, good. Abhi, good. Somi Setti, good. Arey Baba, they all are same. They all are same. 1 carbon atom has a weight of 12 AMU, right or not? And in terms of gram, this is 12 into 1.6 10 to power of minus of 24 gram. So this will be like 1.92 into 10 to power of minus of 23 grams. So that is one. Now 1 mole of carbon is what? 12 gram. Yes or no? And 1 gram atom of carbon is how much? 1 mole of carbon, 1 mole of carbon, which is again what? 12 gram. So either you say 1 mole of carbon or you say 1 gram atom of carbon is one and same thing. And 12 gram of carbon is nothing but 12 gram. So 12 gram and what? 12 gram. They all are same. I mean, boys and girls, you need to have focus. Simply focus. Right or not? So correct answer is 2, 3 and 4 will have the same weight, maximum weight. Is that clear to all of you or not? So I believe that we should do the practice of these questions, right? So after the class is done, please make sure that you are doing practice of these questions, है ना? And revise as much as possible. We'll meet again tomorrow with new set of questions and new fundamentals. Till then, take care of yourself. Goodbye.